In this lesson, we are going to discuss the concept of constants. Constants in C++ are named containers for values just like variables. But unlike variables, the value they store cannot be changed. Before I show you how to work with constants, let's take a look at an example to see when you may want to use constants. This program is an extension of the program from lesson 16. Here, I want to compute the total volume in liters of a 6-pack of 12-ounce cans and a 2-liter bottle of soda. Let's see how this program accomplishes that. First, we initialize an integer variable called cans per pack to the value 6, since there are 6 cans in a pack. Notice that we've used underscores in the variable name to separate different words instead of spaces, since spaces are not allowed. Next, we need to compute the total volume that is contained in a 6-pack of 12-ounce cans. To do that, first, I'll direct your attention to this expression. Here, 0.02957 is the conversion factor for 1 ounce to liters. And since each can contains 12 ounces, this quantity is essentially the volume in liters per can. Multiplied with the cans per pack, we get the total volume of a 6-pack of 12-ounce cans. We store the result of this expression in a variable called total volume. Notice the use of underscore. But also notice that the variable is of type double. The reason why we've used the type double here is because this number in the product contains a fractional part, which means the result of this particular expression will also contain a fractional part. Next, we're simply printing a descriptive message saying a 6-pack of 12-ounce cans contains, and then we print the volume of the 6-pack, and then we again print the unit. Next, we also need to take into account the volume of a 2-liter bottle of soda. So we'll simply add 2 to the total volume that we previously computed. And we'll update our total volume variable to this expression. Finally, we are going to print another descriptive message in a similar format as earlier, but here we are changing our message to state that a 6-pack and a 2-liter bottle contain this total volume. Let's compile and run this program. Notice that our program works well. But notice that we have these weird magic numbers such as 12, 0.02957, 2, and we have put them without much explanation. When some other human programmer or even you yourself look at this weeks later, these magic numbers won't make sense directly. You will have to think about the conversions and then make the connection. This will be especially time consuming when you have to maintain software with a large code base. So let's try to make this program more readable for the average human programmer so that you don't have to open a conversion table to see what these magic numbers are. To begin with, let's state the liter quantity per can and per bottle in a named variable. We've created this can volume variable and the bottle volume variable. The bottle volume is 2 liters per bottle, so we'll simply initialize it to 2, whereas each can contains 12 times 0.02957 liters, so we'll initialize it to that. Next, substitute these variables in place of the magic numbers in line 9 and line 15. This looks much better because if you notice line 9, the programmer only needs a single look to identify what this expression does. But notice that these conversion factors do not really change. They don't need to be variables. If we could use symbolic constants for them, that would be nice. And turns out C++ allows you to create constants. In order to create a constant, start with an initialization statement for a variable, such as this one, and then prepend the word const before it, like this. Let's do the same to our bottle volume. Now that we've created constants, let's go ahead and run this program to see if it really changes anything. Notice that the result is the same as the previous run. By convention, constants are named using uppercase characters to serve as an indicator to the programmer that this particular item cannot be changed. As the name suggests, a constant's value never changes. Let's try to change the value for bottle volume after the initialization. I'm assigning the value 4 to bottle volume. Let's compile this and see what we get. Note that C++ gives us an error. It states that assignment of read-only variable bottle volume, which means the variable bottle volume is read-only or is a constant. Therefore, the value once assigned to a constant cannot be changed. This acts as a good fail-safe check for the programmer in case they try to update the constant. That's it for this lesson. See you in the next one.